Hello guys, welcome back. Now let's have a look over a new ADC, that is analog to digital converter, and it is MCP3428. And to search this sensor, let's roll upon the website, that is controleverything.com, and here we have to type in for the sensor for the ADC exactly, and it is MCP3428. And by searching it, let's see what we got here. As you notice, it's a 16-bit 4-channel analog to digital converter, and these are some more prominent features of this very ADC. And you can also purchase the sensor from this site right from here. Alright, for the interfacing, I will be taking care of ADC MCP3428 with a Raspberry Pi and a Java code. For the software platform will be required, and let's go to resource tab to get the code, and here comes the Java code sample. Click on it and you can get the code as a zip file from this very site. After getting that code, you can also have the option from getting the code from github.com, that is the concerned repository, that is Control Everything community. Now let's look over the hardware connections we need to put up together, and let's see what we got there. Well, in the hardware setup for the connections, what do we require is this Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Next, we require an I2C Shield, which you can see, and it's available on the website controleverything.com. The real reason we are using this shield is to make easier connections with other I2C devices. So for that, gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we need to power up our Raspberry Pi, and for that we require a micro USB cable just like that, and gently insert it over here, the power jack. And for the internet connection, there are two options. First of all, this here is an Ethernet cable or a LAN cable. Now gently insert it over this Ethernet jack, and you are done with the connections part. Now for the other internet connection, we can also have a adapter, a wireless nano USB adapter, just like that, and you can have on the USB port. Next, this here is our analog to digital converter, that is MCP3428, and this here is a connecting cable. Now make sure that while making a connection with the cable and the ADC, the brown wire of the cable should be connected to the ground terminal of the ADC, and similarly to the ground terminal of the I2C Shield. So these are the connections we required for this hardware. Now let's proceed with the code. Coming to the interfacing part, first of all we have to log into github.com, and here we have to search on for the repository, that is Control Everything community. Now after getting this, we have the ADC, that is MCP3428, and here it is, Java code. Let's have a look over the instructions part. As you notice, we have to download and install Pi4j library on the Raspberry Pi, and this link pi4j.com is the link from where we have to install the library. You can notice all the installation steps, commands are there, and please do it carefully. After getting that, we have to download or get pull the code onto the Raspberry Pi, and we have the compilation command here, and this command is to run the Java code. Note it down and we will use it later. After that, we have the Java code. It's a .java extension file, and first thing you notice in the code, we have imported some of the header files and the libraries, and we have created a public class named MCP3428. Now in this part, as you notice, we have bus.getDevice, which will check whether the address of the device is 0x68 or not. Now in the writing part, we are going to select the configuration register, and we are going to send a command for continuous conversion mode, channel 1 12-bit resolution, which comprises of 0x10. In the reading section part, we are going to read 2 bytes of the data from the register 0x00, and then we have to convert the data, and we are using some of the variable procedures, formulas, which we have seen in the datasheet for ADC, that is MCP3428. At the end, we have the output data onto the screen, which is exactly the digital value of analog input. So this is how the code is. Now let's see how it works. Well, let's have a look over the working part, and in this environment, first of all we need to copy the entire code of the Java, and after that we need to look over the terminal for the Raspberry Pi connected via internet, and here we need to paste the entire code. First of all, we need to create a file that will be a .java extension, and here we need to paste the entire code, and after that, as you notice, we have to save it, and the command for the compilation of the step, as you notice on my screen, will be here, and it's a .java file, And let's proceed. And the code is now in the compilation process. It's done. Now for the running of the Java code, this is the command, and we have the raw value of the source, which is 0, which means the terminals of the sensor are grounded or can be open. There is nothing connected right now onto the sensor terminals, but instead when I try to connect a AA battery of 1.5 volt across the two ends, and then we run the command, and we have the value, the raw value of the source will be 1027, and then again when I run it, it will be 1028, which means there is a very slight change regarding the steps of we have followed for the procedure for the working, and this is how the sensor works according to our desire. Now let's have a look over the applications and some of the features and benefits. The MCP3428 is a low noise and high accuracy 16-bit delta sigma analog to digital converter, family member of MCP342X series. This device can convert analog inputs to digital code with up to 16 bits of resolution. Due to high accuracy in analog conversions, the applications of this ADC are portable instrumentation and consumer goods, temperature sensing with RTD thermistor and thermocouple, bridge sensing for pressure, strain and force, weigh scales and battery fuel gauges, factory automation equipment. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.